The surface of Mercury at first glance looks very much like that of the Moon, but in fact, it is different in several ways. The Messenger spacecraft revealed that Mercury has some unique landforms, more smooth plains and surface compositions, low in iron and high in sulfur that are unlike any measured on the Moon. Impact basins, Calories basins, impact site. This is one of the largest impact basins in the solar system and the largest feature on Mercury. The Calories basin is 1,300 kilometers, 810 miles in diameter. Only half of the basin was imaged by Marian in 1970s, but the picture was completed by the Messenger mission. After the impact, the basin was flooded by lava. Ridges and fractures formed when the volcanic rock contracted and stretched as it settled under its own weight. Calories Basin, Rembrandt Young Impact Basin. The Rembrandt Basin displays a wheel and spoke pattern on its central floor that has never been seen on any other planet or moon. Rembrandt brand size comparison. 715 km, 444-mile wide Rembrandt Basin is large enough to cover the northeastern United States. Scarps. A shrinking planet. The surface of Mercury has landforms that indicates its crust that may have contracted. They are long, sinuous cliffs called lobate scarps. These scarps appear to be the surface expression of thrust faults where the crust is broken along the inclined plane and pushed upward. What caused Mercury's crust to shrink? As the interior of the planet cooled, it contracted. Gravity then forced the crust to adjust to smaller interior. Lobate scarps. Discovery Rupes. Another large lobate scarp on Mercury is discovered Rupes. Rupes is Latin for cliff. Discovery is about 550 kilometers, 350 miles long and up to 1.5 kilometers, 1 mile high. Notice that walls and floors of the two impact craters have been deformed by the thrust faults formed by scarps.
Digital elevation model. How do we know how high Discovery Rupes is? One way is to use two images that provides a stereo 3D view of the future using computer the heights elevation of all points covered by a stereo pair can be calculated and a digital elevation model made. Volcanism. Smooth plains between the heavily cratered regions of Mercury surface lie large expanse of smooth plains. Much of the north polar region of the planet is covered by these plains. Outlined in yellow, which may be volcanic basalt deposits several kilometers thick. Flowing lava. The Messenger mission has revealed many features that indicate the presence of volcanism on Mercury in the past. In this image, a narrow channel leads into a large basin near the northern plains. Scientists propose that hot lava flowed through this channel, perhaps carving the terrain as it went. Nearby are odd-shaped pits that may be vents through which the lava flowed. Volcano. This feature is the vent of a small, young volcano located near the rim of the Calories Basin. Halos. The mysterious feature named halos appear on the floor of the crater Tiagaraha. A pit in the center of the center may be volcanic vent. The region of the halo is under study, but may relate to the released gases of sublimation of material exposed by the crater impact. The crater Tiagaraha is named after a 19th century composer from India. As with all the planets, crater names on Mercury are approved by the International Astronomical Union, or IA. Craters on Mercury are named after famous artists, authors, and musicians. Water ice. Data from Messenger have strongly supported the existence of water ice in permanently shadowed craters at Mercury's poles. Earth-based radar data is superimposed on the image of the Mercury North Pole. The yellow areas where the radar signal is reflected strongly are through the B side. The ice is trapped in the frigid dark shadows. Ridges and troughs. Ridges and trough systems unique to Mercury have been observed in messenger imagery. These feature form in relation to ghost craters, impact craters that are filled and buried by volcanic deposits, but whose outline is revealed by ridges that form over a crater rim. The patterns of the ridges and troughs are caused by extension and contraction due to cooling of very thick lava flows and the planet's interior.